Take an AND gate for example. So it has two inputs A and B and an output C, and we know that the relation is C equals A and B. To realize this AND gate in electronics or in hardware, we use something known as transistors. So a transistor is a three-terminal device. It looks something like this. So transistors are the most important components in integrated circuits. So depending upon how many transistors you can have on an integrated circuit, there are four levels of integration. The first one is SSI, or small scale integration. So if your integrated circuit has something less than 50 transistors, then it comes under SSI. Then you have MSI, or medium scale integration. Here typically you have 50 to 500 transistors. Then you have LSI, or large scale integration. Here you have around 500 to 50,000 transistors. And then finally you have VLSI, or very large scale integration, where you have transistors which are about 50,000 or greater. Most modern technologies use VLSI. So if you look at your Apple processor, or let's say the Apple iPhone 15 Pro Max, it has about 19 billion transistors on it. So that is enabled by using VLSI technology. Small scale integration can be used to construct gates. Medium scale integration can be used to construct flip-flops, which are the basic memory elements. Large scale integration, you can construct memory elements or larger memory elements. With VLSI, you can build processors. So what led to the evolution of small scale integration to medium scale to large scale to very large scale? So there is something known as Moore's law. So what Moore's law states is, every 2 years, the number of transistors in a chip area is going to double. So every 2 years, the number of transistors on the same chip area will double. So for example, let's assume that we are in the year 2000. So in 2000, let's say this is our chip area, and we had 100 transistors on it. In the year 2002, for the same chip area, we are going to have 200 transistors. And in the year 2004, for the same chip area, we can fit 400 transistors. So this is what Moore's law states. Moore's law is not exactly a law. It was a trend that was observed by Gordon Moore. So he was the founder of Intel. So Moore observed that every 2 years, the number of transistors in the same chip area is roughly doubling. I prefer to call it Moore's trend or observation. It's not exactly a law, but it's a very common misconception. So as a result of Moore's law, your chip performance went up, speed went up, or you can say speed and performance are analogous, but there is a slight difference. Power consumption went up, which is kind of bad, and you could fit more components in the same space. If you take a cell phone from the year, let's say 2008, and you take a cell phone in the year, let's say 2020, you can see that the phones that were manufactured in 2020 were pretty much the same size as the ones that you found in 2008. But the phones in 2020 have a lot of features which you cannot imagine to see in the phones in 2008 in the same space. And the size is pretty much the same, right? So how did that come up? So how were we able to do it? That is using VLSI technology and Moore's law.